In this lesson, we're going to learn the second method of solving without graphing when we have two equations and we want to know where they meet. So a lot of people like to have sort of rules to follow, steps to follow when they're doing certain types of math. So if you like to have that and you're allowed like a formula sheet or something when you're writing your test, then you could write down these steps for how we do elimination. And right now they're not going to make any sense, so it might be better to go back to the beginning of the video after you've seen how to use them and then write them down. So this will look a lot the same as when we were doing the graphing and the solving by substitution. This time we're going to use a process called solving by elimination, and I really like this method. I don't know why, it's my favorite. What I'm going to do is I'm going to draw some columns on here like this and just a line down here. And what I want to do is just work with one column at a time. So the first column is the x's column. And you might have noticed that we have 2x and then minus 2x. And we know if we have a plus 2 and a minus 2, it adds up to 0. So we have 0 x's left when we add those guys up. If I have 3y and 4y and I add them up, I get 7y. And if I have 8 and 6, when I add those up, I get 14. So what I've done is eliminated one of the variables. That's why we call this elimination. We just got rid of the x variable for now. And the remaining equation is 7y equals 14. If I divide both sides by 7 to solve for y, then I get y equals 2. So already I have the y value of my point of intersection. Now all I have to do is take that value that we got for y, and I'm going to put it into one of these equations. I'm going to choose the top one because it doesn't have any negatives. That's just a little bit of an insurance policy to make sure that you don't make a mistake with your negatives. Okay, I'm going to put a 2 in the place of y, so I've substituted y for 2. And I'm going to solve this. So I have 2x plus 6 equals 8. Now I have 2x equals 8 minus 6 because I'm going to subtract 6 from both sides of the equation to eliminate the 6 on this side. So 2x is equal to 2. And if I divide them both by 2, then x equals 1. So therefore, our POI is 1, 2. And I don't know why, but I find this method the easier way to do it. Maybe because you don't have to do like distributive property or that kind of thing. See how you feel after we do a couple of examples. Sometimes it depends on how the equation's written. It's better to choose one form or the other. Okay, so let's first just draw our columns. So we'll kind of do the same process every time. I'm going to draw a line underneath here for my results. And now what I'm going to do is check and make sure that one of those columns is going to make 0. That has to happen. So 5x and minus 5x right here, those are going to add up to 0, and that's what's required. If I add up the other ones, I have 2y plus 1 more y, so that's 3y. And then I have an equals 0, and then I have negative 4 plus 13. So the positives win by 9 there. So my equation is going to become 3y equals 9. Let's divide both sides by 3. Slashy, slashy, and I have y equals 3. If I want to find the x value, I can choose either equation. Let's choose the second one because it doesn't have any negatives in it. And so I'm going to get y equals 5x plus 13. 3 equals 5x plus 13. I'm going to minus 13 from both sides of the equation. So now minus 10 equals 5x, and if I divide both sides by 5, I know we're doing stuff backwards here. We're solving on the right-hand side, and that might throw a few people off with having the x on the right, but that's okay. Negative 10 divided by 5 is negative 2, so x equals negative 2, and our POI is going to be negative 2, comma 3. Okay, for this pair of equations, let's do our columns. I'm going to draw the line underneath, and now I'm going to check to make sure that one of those columns is going to make 0. 3y plus 3y is 6y, that's not 0. 2x plus x is 3x, that's not 0. And it has to be one of the variables that matches, not the constant, like not the 7 and the 5. So we don't have a column that's going to add up to 0 here. That's too bad. I wonder what we could do to fix that. What if I put a negative here in front of this 3y? Then 3y minus 3y would be 0. But if I do that to the first term, I have to do it to all of the terms. So let's change this to a negative and this to a negative. Now I have 2x minus 1x, that's 1x, equals 7 plus minus 5. Positives win by 2 there, so I have positive 2. So 1x equals 2, or x equals 2. Now I can substitute back into either one of those equations. Let's do the first one since we changed the second one. We'll go back into the first one. I'm going to substitute for x. Instead of x, I'm going to write 2 times 2 here. So 3y plus 4 equals 7. 3y plus, let's do minus 4 minus 4. So 3y equals 3, because 7 minus 4 is 3. So divide by 3, divide by 3. Y equals 1. Now we have a point of intersection at point 2, 1. Okay, so here's another example, and I've already made my columns. Remember the next step. The next step is to check to make sure that one of these columns is going to add up to 0. So the first column is 2x plus 4x, that's 6x. The next column is 3y minus y, that's still 2y. And the numbers don't count in this process. It's got to be the x or the y column that adds up to 0. So how can we fix this? If only this was minus 3y instead of minus y. But that means I'm multiplying the y term by 3. So now I have to multiply all the other terms in that line by 3. So instead of 4x, I'm going to have 12x. And instead of minus 3, I'm going to have minus 9. So now we're ready to add them up. I've got 2x plus 12x, that's 14x. These guys are the column that makes 0. And over here I have 5 negatives, and then 9 more negatives come to join them. So we have negative 14 altogether. So 14x equals negative 14. Let's divide both sides by 14. So x equals negative 1. So let's go back into the equation that we did not change, the 2x plus 3y equals negative 5. We know that x is 1, so we can make that 2 times 1 plus 3y equals negative 5. So 2 plus 3y equals negative 5. Let's subtract 2, subtract 2. So that's gone. Now I have 3y equal to 3. Divide by 3, divide by 3. Y equals 1. So therefore, the POI is 1, 1. Now you might notice a lot of these are coming out to 1, 1 and 1, 2, and that's because when I make up the equations, it's simpler for me to use points that are like numbers that are smaller. But when you're doing the exercises on your worksheet, you'll find that you have a little bit more variety of numbers. For this question, let's draw our columns. We're going to do the same thing every time when we're using elimination. So we'll draw our columns like that. Let's draw our line underneath. And now we're going to check to see which column is going to give us 0. 5x and x makes 6x. 2y and y makes 3y. And the numbers don't count. So I don't have a 0. I've got a choice here. I can do one of two things. I could make this negative 2y, multiply it by negative 2, and then that would make negative 2x, and this would make negative 30. So that would be our new equation. The other thing I could have done was multiply the top row by negative, let me see, the bottom row by -5 to match up with the x's. What I did with the 2 just makes the math simpler because everybody knows they're 2 times tables. So let's go ahead and add them up now because we know we're going to get 0 in this column. We have to get that. 5x minus 2x is 3x. 48 minus 30 is 18. So 3x equals 18. Divide by 3, divide by 3. Does it seem like there's less steps when you do it this way? It kind of does to me. So we have x equals 6, okay? So let's go back into the equation that we didn't change. 5x plus 2y equals 48. We know that x is 6 now, so we can have 5 times 6 plus 2 times y equals 48. So subtract 30 from both sides. I know the numbers are bigger this time, but it's still the same procedure. So we have 2y equals 48 minus 30. 2y equals 18. And if I divide by 2, y equals 9. So therefore, our point of intersection this time is x equals 6, y equals 9. So we always write that at the bottom. We do a little therefore statement, the 3 dots that make like a triangle, and we say POI equals 6, 9. So this is our last example for this lesson. I hope you're finding this method easy. It's a little bit of practice and you'll be really, really good at it, and that's what the worksheet is for. So let's draw our columns again. It's just more visual for me to have the columns there and I can see what I'm really dealing with. All right, let's check to see if we already have a sum of 0 anywhere. It doesn't look like we do. But it looks like if I could squeeze a 2 in here in front of the y, I'd have plus 2 on the top and negative 2 on the bottom. So that means I'm doubling the y value, so it means I also have to double the x value and double the number value. So now I have x plus 6x is 7x. And don't be afraid to use your calculators on these to make sure that your multiplication is right. 2y minus 2y is our 0. And 10 plus 18 is 28. So we have 7x equals 28. There's only one step that we need to do to solve this equation. Just divide both sides by 7. X equals 4. So now we're going to take that 4 and we're going to put it into equation 1. So 4 plus 2y equals 10. And we're going to minus 4, sorry, that's a 10, now this is 16. So now we have 2y, because this makes 0, and 10 minus 4 is 6. Divide by 2, y equals 3. So therefore, our POI is 4, 3. Okay, so I hope that you have found this method easy, and the thing that's going to make it easier is that you're going to do the same steps every single time with this type of equation, and you can just put those steps in your notes and follow them step by step. The more you practice, the better you're going to get at it. Draw your columns, look for a 0. If the 0 is not there, then change the numbers to make it add to 0 and change all the other numbers too. Solve your equation and then go back to find the other variable, okay?